Yeah, so my focus, I'm a nematologist, my focus is really on vegetables and small fruits. We've done a little bit of work on cabbage, but it's really has not been one of our main crops. So let me get started. Just a little bit of background. Nematodes they're often called the unseen or invisible enemy because they're often not recognized by growers because they do their damage below ground. Their symptoms above ground are not very typical and often confused with other problems. And of course, they're microscopic. So this is what a typical nematode looks like. It's a microscopic, long, thin roundworm. The typical feature for a plant parasitic nematode is this stylet at the top of the head. It's like a spear or a hypodermic needle that the nematode uses to pierce plant cells, root cells, and feed itself. So it's a fairly complex organism. It has a reproductive system, digestive system, even a small nervous system. Let me go back here. I do want to point out that when you think about soil, there's definitely a lot of plant parasitic nematodes, especially in agricultural soil, but still the majority of nematodes in your soil are not going to be plant parasites. The majority are going to be nematodes that feed on bacteria, on fungi, or on other nematodes, and they all play an important role in the whole nutrient cycle process in your soil. So keep in mind that nematodes are the most abundant multicellular animals on the planet. So, any bit of soil, any handful of soil will typically contain hundreds to thousands of nematodes, mostly beneficial. Just to give you an idea, the size, as I said, they're microscopic, but there is some variation in size and length. They're all very thin, so that's why they're pretty much invisible. But the size, the length pretty much varied from a quarter inch for the largest nematodes, like Longidorus, Dolichodorus, Belonolimus, to 1/60th of an inch for the smallest nematodes. Also notice that some stages of nematodes are no longer worm-like, but they become kind of almost round, like in case of root knot and cyst nematodes. On top of that, let me go back here. On top of that, you see a tip of a pencil, just to give you an idea of the relative sizes of these different nematodes. It's also important to realize that nematodes feed on roots in different ways. The most damaging nematodes are often endoparasitic, means the nematode completely enters the root system. And you can see that on the transect of a root on the left, these round nematodes like root knot and cyst, they develop completely inside the root. Other endoparasites like lesion nematodes, they keep their worm shape, but they will also completely enter the root system. Some are semi-endoparasites like reniform and citrus nematode, they only partially enter the root. But really the majority of nematodes, plant parasitic nematodes, are ectoparasites, so they will just feed on the outside of the root like sting, stubby root, ring, and dagger nematodes do. So as far as co-crops, I've listed here the most important nematode pests. Globally, the number one nematode on Brassica crops is probably the sugar beet or the beet cyst nematode, Heterodorus cacti. It's an endoparasite. Root knot nematodes are important parasites of Brassica crops as well. They're also endoparasites, as well as lesion nematodes, Pratylenchus species. As far as ectoparasites, the most important ones are probably stubby root nematodes, and especially in Florida, also sting nematodes and all nematodes. All and sting nematodes are very similar. They're related genetically. So those are ectoparasitic nematodes. I'm going to talk a little bit more about some of these different nematodes. As I said, globally, the beet cyst nematode, Heterodorus cacti, is the most important. This was actually one of the first plant parasitic nematodes that was ever discovered around the same time that root knot nematodes were discovered. Beet cyst nematode was first found in Germany in 1859 on sugar beet, and it really caused a lot of havoc to the sugar beet industry. Dozens of sugar beet sugar factories around that time had to be closed because of this nematode damage. This is more specific. It doesn't have an extremely wide host range. It mainly reproduces and causes damage to beet crops, to brassica crops, and chenopodium crops, which is like spinach. It's one of those. In Florida, we really have only found one report of this nematode on cabbage going back to 1970 by Harlan Rhodes. Other than that, I haven't found anything. So I don't think this nematode is really a problem in Florida. It is quite a big problem in California, especially in the Imperial Valley, where they have a long history of sugar beet production, and it causes a lot of damage on brassica crops grown there in the Imperial Valley now. So if you look at the global map, you see it's got a worldwide global distribution, but mostly in more temperate regions. So it's not very common in the tropical regions of the world. So this is more a type of nematode that prefers temperate climate conditions. You can see the picture here on the top. It's the cysts that these nematodes form on the outside of the roots, which start out as white and then they turn brown, but they can be pretty easily seen with the naked eye. So root knot nematodes, this is by far the most damaging nematode worldwide, and certainly also in Florida. It's very common in our state. We have more than 15 species. These nematodes have an extremely wide host range. There's actually very few plants that will not get damaged by this group of nematodes. There's a lot of interactions with soil pathogens. In Florida, we have interactions with root knot and fusarium in tomato that are quite common. In cotton, there's interactions with verticillium wilt, just to give a few examples. There's probably a lot more interactions that we're not aware of at this moment. And of course, they typically form these galls or knots on the roots, as you can see on the picture, that tomato root on the right. The life cycle is, it's an endoparasite. So you have these juveniles that move around in the soil. Once they enter the root, they become sedentary. They're not going to leave the root anymore, and they turn into these sausage and eventually pear-shaped females that produce these big egg masses containing hundreds of eggs. The life cycle in Florida for most root knot is about 3 to 4 weeks. So, you can get multiple generations in one crop. This is some damage from root knot on cabbage in Florida. This is from a colleague of mine, pictures from Zane Grabau, who's a nematologist up in Gainesville in our department. But it shows you the typical symptoms that nematodes will cause, especially root knot nematodes on crops. So you see these stunted cabbage plants, kind of patchy. It's not very uniform in the field. When you look at the roots, you can see the galls, the knots on the roots. Late season, you can see some yellowing, some mild chlorosis on some of these Brassica plants, and just basically, stunted plants due to severely reduced root system. So these plants are just not effective anymore in providing the plant with water and nutrients. Sting nematode, Melonolinus. This is a very important nematode in Florida, especially in our sandy soils. It's really a true Floridian nematode. If you look at the global distribution, it's mostly the US, and in the US, it's really also mostly the coastal plain soils, like the sandy soils, where we find this nematode to be quite common. Some of these other countries where it's been spread, likely with infested sod coming from Florida. It's an ectoparasitic nematode. It's a large nematode. It's got a very long spear stylet, so it can do a lot of damage to a small root system. It's one of the main problems in strawberry production in Florida. It causes these stunted, small strawberry plants, and it really does a lot of pruning on these small roots. So you have these stunted plants that you can pull out without any effort because the roots are pretty much completely gone. It's got a very wide host range. I mentioned strawberry, but it can also cause a lot of damage to vegetables, to citrus, to a lot of field crops like corn and peanuts. Turf grass, sting nematode is one of the main problems there as well. We still consider this nematode a single species, but there's definitely a great deal of diversity in morphology, host preference, and genetics. So likely this species is actually different species. It's a species complex, but we haven't done really much work on that. This is some damage from sting nematode nearby. This is an organic farm here in Waimama, growing broccoli and cabbage from a few years ago. Again, you can see the stunted plants here on plastic on the left. These plugs, broccoli plants, they never put out any roots. As soon as they put out roots, the sting nematodes will attack them and they just stop growing. So the plants pretty much never grow. Interesting in this field, and this is just observational, this was not an experiment, but while we saw quite a bit of stunted, patchy areas in the broccoli beds, there was some cabbage beds rows nearby that looked almost normal, where the damage was much less. So possibly there is some difference in susceptibility among different brassicas, and definitely looked like broccoli was more susceptible or sensitive here than cabbage. So a little bit about nematode management. I always advise people to use an integrated approach, and this is a simplified chart from this new book that came out recently on integrated nematode management, which you can download for free. I put the link on there from the CABI website, so you can download the whole PDF of this book for free. There's a lot of chapters on from all places around the world, focused on specific crop nematode situations, several from Florida as well. But basically, integrated nematode management is there. We look at it as based on 5 pillars, basically. One of them is crop rotation, which includes cover crops. Another one is cultivar choice, which includes resistant cultivars. Unfortunately, for brassicas and cabbage, I'm not aware of any nematode-resistant cultivars available. I think there may be some that have resistance against this beet cyst nematode, which is not an issue for us. Soil management is another pillar. In our sandy soils, adding organic matter is always a good thing to stimulate the biology in your soil that may help control some of these plant parasitic nematodes. Of course, targeted control, which includes nematicides, biological products, and then there's also monitoring and evaluation, which is important. So I'm just going to talk a little bit about some of the things here. This first is the list of nematicides that you can use in brassica and cold crops in Florida. This is from the Vegetable Production Handbook. So the fumigants are still available in brassicas. You can use products like Telone, like chloropicrin, metam-based products like Vapem and Kpem, and also Dominus AITC is available as a fumigant. As far as non-fumigants, MoCap, old organophosphate nematicide, is still available. And then there's the new nematicides, Nimitz and Vellum, which have become more recently available to growers. As far as biologicals, I just want to mention Magistine, which is based on dead bacteria from Burkholderia, and Melicon, which is a live fungus, Purpureosylium. There's also several essential oil products that you can use as biological control. This table just shows you the nematicide profiles, the synthetic nematicide profiles, and I color-coded them to kind of indicate the relative safety of these products. Obviously, fumigants have a danger label. The same as MoCap, etoprophos, it's an old organophosphate, so it's pretty toxic as well. And the new products like Nimitz and Vellum are very different as far as safety. So they only have a caution label. They're very safe to the operator. So it's really nice to have some, for the first time really in history, that we have some actual nematicides that don't have a danger label anymore. I also want to point out that some of the physical properties, the solubility in water, the soil half-life is quite different for some of those products. For instance, fluoparem vellum is not very soluble, which means it's not going to move very well in your soil. But it does have a very long half-life, so it's got a long residual. It's going to hang around for quite a while, which is very different from some of these other nematicides that really don't hang around that much. These new nematicides also have new modes of action, which is obviously a good thing. In the past, we only had these cholinesterase inhibitors as well as the fumigants. So it's nice to see some new products, and I think we'll probably be seeing some more new products coming in the market in the next few years. Cover crops, this is part of the crop rotation pillar, is something that, I believe every grower should try to incorporate into his management system. Cover crops can help in nematode management because they are non-hosts to the nematode that you're targeting. Some of them can also produce toxic root exudates or breakdown products that help kill nematodes. And most of them will really increase the activity in the soil food web and stimulate some of these nematode antagonists that are common in soil. So what about cover crops and nematodes in Florida? So this is just a brief summary of some work that we did. looking at the host potential of these different nematodes for cover crops. So as far as root knot nematodes, you will decrease your root knot nematodes when you plant sun hemp and sorghum Sudan grass. So those are really good cover crops if root knot nematodes are your target. You don't want to plant sunflower. It will increase root knot nematodes quite significantly. And also cowpea tends to increase root knot nematodes, but with cowpea, it really depends on the cultivar that you use, as well as the root knot nematode species that you're dealing with in your field. Sting nematodes seem to decrease with sun hemp. We don't have too much data on it, but that seems to be the trend. So sun hemp's a good one for sting nematode as well. But you don't want to grow sorghum Sudan grass if sting nematodes are a problem in your field, because they will increase with this cover crop. The same for stubby root nematodes. They really like to feed on sorghum Sudan grass. And lesion nematodes, both sun hemp and sorghum Sudan grass seem to increase these numbers. So basically, there's no single cover crop that will take care of all your nematodes. So one of the strategies that we're trying to look at now is see if we can mix some different cover crops and see how that influences the nematodes in the soil. It may be a better tactic to use mixtures as to not select for one specific nematode too much. Also, as I said, some cover crops may produce compounds that are toxic to nematodes. Sun hemp is one of those. We did some testing with sun hemp plant material, both root and shoot material, incorporated in some of these boxes, add nematodes and see how many survive. You can see that both below and above ground material really give quite a significant reduction in root knot nematodes. And we tested it both under aerobic and anaerobic conditions, and especially under the anaerobic conditions, we see a really significant decrease or nematocidal activity of the plant material, both root and shoot material. So that's another benefit that we see with sun hemp cover crop. I also want to mention that Brassica plants themselves contain certain allelochemicals. Now, most of the commercial cold crops, they've been selected to have low content of these allelochemicals because it kind of impacts the flavor, the taste, because these are sulfur compounds. So they may give a strong odor or sometimes, something that's not really palatable to people. But there's also some of these brassicas that now are being bred to contain high allelochemicals. So there's certain mustard varieties, certain radish varieties that are being bred as with a specific purpose for biofumigation use. So the background here is that all these brassicas contain compounds which we call glucosinolates, which is basically glucose molecules with a sulfur substitution on it. So they all contain it. These are not toxic in themselves, but when they break down, when they hydrolyze and combined with the enzyme inside the plant called myrosinase, they produce a bunch of volatiles and toxic compounds. One of them is our isothiocyanate. So this is basically the active ingredient of products like K-PAM and VAPAM, as well as a bunch of other volatiles. So this is kind of the little overview of, if you want to use brassicas for biofumigation, how you would do that. We've done some work in the past where we planted brassica cover crops in winter. So you can plant your mustard, your radish in winter. Early spring, you mow them. They do really well in winter. You mow them, you rototill them in, apply some fertilizer, and then you irrigate them. It's important to add enough water because it's a hydrolysis reaction. You can build plastic beds on top of it to kind of trap the volatiles, and then you can plant your vegetable crop. In some areas, they have had pretty good success. I think in California, they have a system that works quite well. I don't think we've had that much luck with it here in Florida. One of the problems with some of the brassica crops, as I said earlier, is that they're actually good hosts to certain nematodes like root knot. So while you grow the crops, you may actually increase some of the nematodes. Anyway, it's just something I wanted to mention that's an opportunity for some people. And then finally, and this is kind of a no-brainer, but I just want to mention it to finish, is that sanitation is really key with any type of nematode management. You have to realize that nematodes mostly spread passively, so they don't move too much on their own, only a few feet horizontally. So most of their movement is with soil, water, or with soil movement. So across fields, you may spread nematodes around through your, soil stuck to your tractor tires. If you get flooding events in or around your field, that's going to move nematodes around. And of course, across states and countries, some nematodes will be in tubers, potato tubers, sugar beet tubers. We found, occasionally or quite frequently, actually, we find nematodes in strawberry transplants that come out from out of state. So sanitation, making sure you don't introduce nematodes in your field is another key component. I think that's all I had. So I just want to point out some of this, more information on some of this you can find in some of these IFAS publications. I added a link here. One is in English, another one is in Spanish. And you can always shoot me an email if you have some additional questions. Thank you.